Hello. Question number 2. The graph in figure 1 show the motion of the body. So this is graph velocity versus time t, and we have time taken. The whole process is 6 seconds, and this is a maximum velocity 40 meter per second. Question number 1. Ask you which part of the graph show the body is moving the maximum speed. If you look at the graph here, the maximum speed is 40 meter per second, and it happened at the 3 to 4 second, or the point C to point D. This is number 1, and number 2. Calculate the maximum acceleration of the body. The question asks you about the maximum acceleration. If you look at the graph here, from A to B, B to C, C to D, and D to E, the position A to B is referred to the maximum acceleration, because the gradient is a maximum. So meaning here, for the gradient here, you can use the triangle here. The triangle here meaning you have a acceleration is equal to 20 divided by 1 second. So this is A is a 20 meter per meter square. This number 2, right? And number 3, calculate the average velocity of body for the first 3 seconds. Average velocity. So average velocity is a total distance, right? Total distance or displacement divided by total time t. So total distance here, because this is graph v versus t, for graph v versus t, you can find the total distance here is the area under the graph from 0 to 3 seconds, because this is the first 3 seconds. So now you can find the value of the area under the graph. Area under the graph for the first triangle, and this is a trapezium, right? And now for the first triangle, we have a half, right here, right? So V average is equal to the first triangle area is you can use equation half, height is 20, and the base is 1 plus, and we have a trapezium. The area of trapezium, you can use the equation half. We have a parallel line 20 here and 40 here is 20 and 40, meaning 20 plus 40, and time for the trapezium here, this is 1 to 3, meaning 3 minus 1 is equal to time 2, and divided by t in 3 seconds. And you can use the calculator here. We can find the V average is equal to 23.3 meter per second. This is answer number 3. Next question, number B. State the one similarity between free fall and projectile motion. So if free fall motion, so meaning here, if you draw the diagram for the free fall, let's say you have a object, right, or ball, and this is a ground surface. Next, you release the ball from the rest, and the ball moving to the downward. So this is the free fall. And the second is a projectile motion. Projectile means, let's say you have an object, right, and you release object, right, from the height of, right, edge from the ground surface, right. So let's say you push the ball, and the balls after that the ball moving in the projectile motion and touch the ground surface here, right. This is a ground surface for the free fall object. So this is projectile motion, right. So free fall and projectile. The similarity between the two processes here, free fall and projectile, is both of free fall, right, and projectile motion influenced by the gravitation g, or you can refer to the g is 9.81, right, 9.81 meter per second square, and the direction both for free fall and projectile is the downwards. Next question, a ball is thrown upward with the initial velocity 10 meter per second. You can see from the diagram of figure 2. So this is initial velocity of the ball, 10 meter per second, and the angle is 60. And at the same instant, a stone, so this is the stone from the initial position at the ground surface, throw vertical upward. So the ball is thrown vertical upward with the u in the initial velocity u. I show in figure. Calculate the value of the u, or initial velocity that the both object will collide at the point P. Meaning at the point P here, we have two object collide, ball and the stone at the point P. The question asks you what is the velocity or initial velocity of the stone. So for the stone and the ball collide at the point P, meaning the distance of the ball, right, have the same value. This is the ball, and have the same distance or displacement for ball, and the stone is the same value with the time t, the value of time t for the ball, time for the ball also is equal to the time to the stone here. So if the SB is equal to SS, here the ball or the stone and the ball will collide each other at the point P. And you can use the relation between SB and SS here. For the ball here, you can use the vertical axis, right? Vertical axis for the Y, this is X. So this is U, this is UB. So you can resolve to the UBY, meaning resolve 10 meter per second to the vertical, meaning you can use the U for UY here, so I write here is a 10 sine 60. This is initial U for the vertical axis, right? And for the stone here, U is only on the Y axis, right? Meaning the U here is a UY, but this is for the stone, and this is for the ball, right? So you can use the equation and elaborate the equation here, because the acceleration displacement equation, you can use equation Sy is equal to Uyt minus half gt square. This is for the both item SB and SS, right? So we have two equations for to left and the right, and for the SB here, so you can use the equation for this is for the ball. So we have a sy here, because this is value here is a uy, so meaning the uy here is a 10 sine 60, 10 sine 60, and time t, right? Time t minus half, g is constant, 9.81 time t square, So this is for SB, for S ball, right? Ball. So what happened to the SS? So SS here, so SS, right? So you use the same equation. So for the SS we have only the uy, because no value of the ux, meaning you have a uy. Uy is the initial value of the stone, time t minus half gt square, right? Minus gt square, and this is SS, so this is SB, right? Yes, and the uy here is, yes, uy t minus half, g is 9.81, and we have the t square. So you can use the equation for the SS, because SS is equal to SP, so meaning you can use the equation here. This is 10 time 60 time t minus half, 9.81 t square, right? Okay. The next, what happen is, because we have the t and t square to the left and to the right, so we can cancel for the t and the t square. Okay, and the next is we have, because this is 10 sine 60, and this is 9.81 divided by 2, and the same process here. The final answer, you can use the uy here, or initial u for the stone, is equal to 8.66 meter per second, right? So thank you.